Very warm welcome to everybody to our webinar. Please feel free to ask any questions in the questions box during the webinar. We will answer these questions by the end of the session. That's one. And another one I would like to point out is that we would very much like to receive your feedback via the survey after the webinar. So please fill out the survey so we can improve our webinars in the future. Thank you very much. We will talk about today about evaluating OT cyber resilience through red teaming, and in this day and age, this is very necessary to do. Who are we? My name is Remco Huisman. I'm a senior account manager at Secura within the industrial market group. And Jos, who are you?
My name is Jos Wetzels. I'm a principal security consultant with Secura, and I mainly focus on OT and industrial control systems. And prior to joining Secura, I worked as a researcher at the University of Twente in the Netherlands, focusing on critical infrastructure protection.
So two slides about Secura, who we are and what we do. We're a company, cybersecurity company focused on IT and OT and IoT, and we provide insight into your cybersecurity. We are divided into different market groups. This webinar is being hosted from within the industrial market group, and we provide a lot of services divided over people, process, and technology. I will dive into this a little bit deeper. So from the people side, we provide security awareness and behavior program, including an OT e-learning module. But we also provide, for example, training courses, ICS SCADA and security and hands-on OT hacking. We can also help companies with a secure software development lifecycle program. From the process point of view, we help organizations with measuring their IT and OT security maturity, and we do this against the NIST cybersecurity framework and/or IEC 62443. We also help companies to prevent getting a victim of ransomware, and we also provide, for example, IEC 62443 gap analysis and IT/OT risk assessments. A lot of services in the process point of view. Within technology, we do a lot of IT/OT security testing, threat modeling, penetration testing, design reviews, code reviews, and of course, red teaming in these environments. And that is the topic for today. Take it away, Jos.
Thanks, Remco. So we'll start this webinar off with an overview of the relevant threat landscape as it pertains to the subject matter we're going to discuss, followed by an introduction on what red teaming actually is and its nuances in the OT domain. And we'll finish with a scenario walkthrough to illustrate some of the concepts we're going to talk about today. At the end, there will be a Q&A session, so make sure to stick around for that if you have any questions. So let's start with the threat landscape. Now, in the past decade, as you can see on the slide, we've seen several incidents with either a successful or an intended operational impact, from the famous Stuxnet attack on the nuclear facilities in Iran and the attacks on the Ukrainian power grid to attacks on a Saudi petrochemical safety systems and Israeli water utilities earlier last year, as well as a recent wave of attacks against Iranian critical infrastructure, which, while not necessarily targeting the OT systems themselves, managed to cause massive operational disruption anyway. Now, these incidents come from a wide variety of possible threat actors with very different capabilities and motives, ranging from state-sponsored actors motivated by geopolitics to cybercriminals motivated by financial gain and everything in between, really. While the state-sponsored attacks with cyber-physical impacts, like Stuxnet, tend to draw the most attention in the OT world for obvious reasons, financially motivated attackers are on the rise in recent years and shouldn't be neglected. As you can see on this slide, this is just a sample from ransomware attacks against OT organizations in the last few years. And it's fairly evident that virtually every sector across the globe is being hit with serious financial and sometimes operationally disruptive consequences. Now, a lot of these ransomware attacks that we're seeing are driven by the phenomenon known as big game hunting. And much like its namesake, these attackers specifically target large and critical organizations for financial reasons. They study them for weeks or months, and then they carefully select them based on various factors, such as ease of access, ability to pay a ransom, and very critical for the industrial sector, sensitivity to downtime and bad PR. Because obviously, the longer your organization is down, the more money you stand to lose, and the more attractive paying a ransom seems in comparison. And attackers know this, so this is why they're targeting certain organizations, like the Colonial Pipeline hack we saw earlier last year. And the extortion is typically double, since they don't only encrypt and lock target systems, but they also exfiltrate a subset of the sensitive data. So not paying won't only result in downtime and data loss, but also in some of the data getting leaked to the internet. Now, the ransomware sums demanded by these type of gangs can range from the tens of thousands to the millions of dollars, with the average in 2021 being roughly $170,000. Now, what enables these gangs to operate as effectively as they do in recent years is that they exist in a highly professionalized criminal economy. As you can see on the slide, multiple different criminal specialists exchange services from the actual ransomware developers to initial access brokers, who might not be connected to the ransomware gang itself, but only specialize in selling vulnerabilities or credentials obtained through phishing, social engineering, and third-party breaches, to a ransomware as a service provider, who then contract different parties to put together these packages, which are provided for a commission on each ransom to affiliates who carry out the actual attacks. So in this way, victims might end up in the sights of an initial access broker accidentally through maybe a data leak or an exposed vulnerability, and essentially get sold off to a ransomware as a service provider as easy prey. Now, luckily, in recent years, OT security controls have come a long way from baseline compliance to advanced intrusion detection systems, endpoint solutions, and SOC SIEM solutions. But how do we really evaluate the actual effectiveness of these investments in a holistic and independent manner? How do we know that all this effort we've gone through to harden our systems actually works and does what it needs to do? How do we know if the controls work as intended? How do we know if our organizational processes actually work smoothly in practice? How do we know if people will panic during a real attack? And how do we know if we missed anything major? It's very hard to be aware of your own blind spots, of course. And this is where red teaming comes in. Now, red teaming consists of an operation or a series of operations being performed by a so-called red team, which is an independent group who performs full spectrum offensive engagements, targeting the organization as a whole, rather than only pen testing individual parts of the organization, with the goal of improving overall cyber resilience by focusing on multiple security domains, from people to process and technology. It's essentially the ultimate cybersecurity fire drill. And typically it operates along the kill chain, as you can see on the bottom of the slide, with the initial stages consisting of the planning, then moving on to reconnaissance, exploitation, post-exploitation, either exfiltration or, in the more OT-oriented cases, impact demonstration, and finalizing by clean closure, where you ensure that nothing is left behind and all the stuff that has been uncovered is remediated. Now, a red team will operate, as we earlier said, across the spectrum, and this includes physical attacks like lockpicking, sneaking into a building, batch clothing, that sort of stuff, to social engineering and phishing, to dropping rogue implants, either on a laptop or maybe in an embedded device, and remotely hacking networks, either wireless ones or wired ones and everything in between, all in order to cause a simulated high impact event and test an organization's responses to this. Now, the key results for an organization for red teaming are as follows. It allows you to train your defenders to identify any unknown weaknesses, to test the impact of known vulnerabilities, to assess your response procedures, and to finally raise awareness The results of a red teaming engagement can be shared within an organization as an internal case study, not only on how well you performed, but on what an attack would look like as it plays out within that particular organization. So let's zoom a bit into the nuances of red teaming into the OT domain. First of all, while red teaming strives for high realism, it's very important to note that controlling risk is always paramount, but especially when you're dealing with operational technology. Simulated attacks should never influence the target's business continuity or process safety. And in order to ensure that, there's some risk mitigation which needs to be taken into account for OT red teaming. From potential damages and unwanted side effects to incorrect attribution or internal consternation, you need to mitigate these by doing a combination of actions, from screening the red team to very clear coordination between the different teams. So that's the red team, the blue team, and the white team, which I'll introduce in a little bit. To having clear rules of engagement, so what network segments you can touch, under what conditions, what actions you can take within each different network segment, what things you will be able to test in an acceptance environment or which you will be able to test in a production environment, and having a clear ethical code of conduct around the operations you take. So one of the questions you often hear in these kind of setups is, if you're collaborating this close with the defensive organization, is it still red teaming? Because red teaming strives for a high degree of realism, and usually the blue team is kept as much in the dark as possible. And that's true, but the way you essentially meet in the middle is through a purple teaming approach, where you integrate the offensive side, the red, and the defensive side, the blue, under the supervision of a white team, which consists of selected individuals from the blue side, from management, who are in the know and able to coordinate all these different stakeholders into a coherent, realistic, but also safe red teaming engagement. Now, one of the other differences in the operational technology world is the difference in crown jewels. So in an enterprise environment, you might be, as an attacker, looking mainly for personal identifiable information in databases, code repositories containing intellectual property, or file shares with business information. Now, in operational technology, you're more focused on things like SCADA servers, DCS recipe storage, and safety controllers. But after all, it's more important in the end to focus on the mission and not the assets. It's very easy to miss the forest for the trees by focusing on the threats to particular assets and what could go wrong with a particular system or device. But what we really care about is the ability to provide clean water or provide reliable energy, and not PLCs or routers in themselves. We only care about these assets, these crown jewels, insofar as their malfunctioning degrades the mission. And that's the perspective where red teaming with operational impact has to really depart from the question, how do we disrupt, degrade, or deny the mission of the target organization? And one way to start in order to develop a viewpoint on this is by taking existing safety and process info, like process hazard analysis, HAZOP studies, and process flow diagrams, and together with experts from the white team, distill this into a prioritized list of high consequence events. So the scenarios that you're typically trying to avoid occurring. And then from these events, work our way backwards to attack scenarios. How could we, through cyber-enabled means, cause such a scenario to take place, like degrade the product quality or disrupt the reliable delivery of electricity? And at the end, out of those attack scenarios, we get a high-level overview of the involved crown jewels. So the question becomes, like, if we want to disrupt the delivery of electricity, we can take scenario A, B, or C, and in each of these scenarios, certain crown jewels play a role. And that's where you get a picture of the attack path before you start. Now, developing OT attack scenarios is a nuanced process which involves many different disciplines and stakeholders, from engineers who are able to understand the physical process itself, to systems analysts who understand how the physical process and digital technology fit together, and hackers who are able to find flaws in these systems and develop the capabilities to exploit them. And all of these disciplines will need to coordinate already during the planning stages of a red teaming engagement in a OT environment. So in order to structure these operations, we typically use 3 major phases. And these phases are depicted sequentially, and typically that's also how they play out. But of course, the boundaries between one phase and the other can blend in practice. So please keep that in mind. These phases typically start with the directed collection operations, where attackers will first infiltrate networks to obtain the necessary information to understand the OT domain, to understand the processes that they're targeting, and to get really a process comprehension of the target that they're after. Once an understanding has been developed of the network architecture, strategic access is obtained to key OT systems. And once these key OT systems have been compromised, a deeper understanding of the systems and processes in question is combined in order to develop an impact scenario, such as opening a circuit breaker in a power system or manipulating the valves in a pipeline to achieve a certain effect. Now, to give you a couple of ideas of what this looks like, directed collection operations have been taken place by various threat actors in real life. One campaign is the Dragonfly campaign, who have been targeting Western utilities over the past years and obtaining various pieces of information from network and organizational designs to equipment models, wiring diagrams, HMI screenshots, and other OT information, probably in preparation for either later attacks or developing the capabilities to carry out such attacks. Now, an example of the subsequent phase, the strategic access operations, would be the various reports that you sometimes see in the media about preparing the battlefield, or as they sometimes call it, defending forward, which would consist of obtaining long-term access to certain targets. For example, uranium enrichment facility in the case of Stuxnet, or the power grid in order to be able to implement a kill switch, which could be flipped at a desirable moment later in time as retaliation or act as of deterrent. An example of the final stage, which are sometimes called non-kinetic computer network attacks, would be, for example, Stuxnet, which damaged Iranian nuclear centrifuges, or the blackout attacks on the Ukrainian power grid, or for example, the Triton attacks against the safety systems of a Saudi refinery. There are different motives for such destructive attacks, which can range from concrete geopolitical goals, as was the case with Stuxnet, to strategic signaling, which would be that an actor wants people to know that they're capable of a particular act, or maybe live experimentation in preparation for something else. Being able to develop your capabilities, see how that plays out in practice, and see how people respond to it can be a motivation for carrying out something like this. Now, when we're carrying out simulated collection operations, we will use, again, a combination of different techniques, ranging from physical access at locations to setting up custom spear phishing campaigns, to gathering open source information or targeting OT information as it resides already in IT networks. Then strategic access operations, you can see illustrated on this slide, where you can take different approaches to achieving the access you desire. So if we're looking to get access to central OT systems, we might approach them, for example, from decentralized field stations, where we manage to get physical access to decentralized field stations and then hack our way up into the central stations. Or for example, we might simulate a supply chain compromise in order to be able to get access to the systems we desire. Or we compromise the traditional IT systems and then move laterally to the OT systems across the perimeter. And finally, when going for the cyber physical impact, we typically design an attack scenario in close collaboration with the white team, which we will then simulate in an acceptance environment or a lab environment in order to balance realism and safety. Because obviously you cannot carry out these kind of scenarios in the real production environment. You will have to do so in a simulated manner. And then there's adversary simulation with the MITRE attack framework. So the question here is, how do we emulate attacks in a manner that's both realistic but also measurable, that's concrete, that's more than just a report with one testing team's opinion? Now, one way to do that is by drawing upon the industry standard MITRE ATT&CK framework. MITRE ATT&CK is a knowledge base of adversary tactics, techniques, and procedures, which is based on real-world incidents and research, and provides a common language and structure that allows us to break down incidents into granular, retestable pieces of knowledge. And the TTPs of real OT adversaries are already mapped to this framework. And one can use these TTPs to compose an attack campaign in order to train defenses effectively against the most relevant threats, providing essentially a scorecard of which the TTPs were successful, which ones were detected, which ones were maybe unsuccessful but not detected. And this way, you should not see it as a checklist, but it gives you a view of the constantly evolving nature of threats and an indication of the areas in which you stand to gain the most from attention and improvement. So for example, if you see a lot of negative scoring around credential access, that is a clear indication that your organization will need to do some improvement there, rather than focus on the individual TTPs themselves necessarily. Of course, we cannot look at these TTPs in isolation, but we will need to contextualize them within an entire campaign. And this can be done by building a so-called adversary emulation plan, where we first analyze the threat landscape, like we discussed earlier, and then filter out the most relevant threats for a particular sector and a particular organization in relation to the consequences we identified for this organization. Then we extract the relevant TTPs and distill an emulation plan on that basis. We develop the capabilities we need in order to emulate this adversary, and then we carry out the actual operations as we discussed them. And in this way, you don't look at isolated vulnerabilities, at isolated tactics, at isolated ways to get into systems, but you look holistically across the attack life cycle to emulate real-world adversaries. Now, one source where we can draw upon these TTPs is Secura's Operational Technology Cyber Attack Database, which is a database that maps 133 OT incidents from the past 30 years to the MITRE ATT&CK framework. Now, I won't go in depth on this now because on December the 7th, we'll be having a webinar on this. So I encourage everyone to register and take a look at this because it really matches nicely with what I'm discussing today. So what does this look like in practice? Now, let's walk through a recent incident using the different stages and TTPs from MITRE ATT&CK as a guiding playing book for what could be a red teaming scenario. Now, the incident I want to discuss took place in April of 2020 in Israel, and it consisted of a series of attacks against water sites in an agricultural region and in the center of the country where attackers reportedly attempted to manipulate chlorine levels, which is already bad during a pandemic, but also during what at the time was a heat wave. So while it was unclear what kind of information gathering in the initial stages was performed by the attackers on forehand, one of the things you typically do as a red team is using open source intelligence. You'd be surprised how much can already be found in the open. Now on the slide, I have some redacted information from various ICS targets in the Netherlands, mainly the water sector. And the fact that many of this information is available is the result of heavy regulation of the public sector, which means that tender documents or sometimes very in-depth ICS information has to be made public and is available for potential attackers. So a few simple searches typically give you information about everything from network diagrams to process diagrams, asset inventories, to even detailed field bus and alarm mappings. And keeping this kind of information that it might be out there in mind is very important for the point of view of an opportunistically targeting attacker. It might be the case that these attacks were not necessarily targeted against these water sites, but the attackers just happened to stumble upon them. And because they were easy prey and there was information out in the open, that's why they actually targeted them. So the second phase was the initial access to these systems. Now the attacked water sites were fairly remote, and they were likely connected to a SCADA system over the internet by means of cellular gateways, which, due to configuration issues, rendered the PLCs either directly or indirectly exposed to the internet. And reportedly, there were no credentials or default credentials on any of the gateways and PLCs in question, which is very similar to an incident a few years ago with the Bowman Dam in New York, which is a small dam which was targeted by hackers opportunistically in a similar way. And as you can see, these two ways of getting access, the internet accessible device and the default credentials, are both mappable to the MITRE ATT&CK framework under different TTPs. You can use this to build up your campaign and essentially stitch it together from these TTPs from the incident. Now, I did a quick scan of various Israeli systems exposed to the internet before this webinar, and it reveals quite a few OT protocols which were directly exposed to the internet, as well as the cellular gateways in question. Now, of course, these could be honeypots. It's not possible to tell from a quick scan, but there were quite a few of them. And in a red teaming operation, we would similarly scan for exposed systems on part of the target as part of our ways to get initial access. Now, once connected to these systems, the attackers communicated with the PLCs using standard OT protocols on common ports. For example, some of the stuff that we found open and exposed was Siemens S7CON, we found Modbus being exposed, we found General Electric SRTP being exposed, and all of these OT protocols requires either just the vendor's engineering tools to interact with them, or if you have a little bit more of an advanced attacker, understanding of the protocols themselves. And we can map these ways to interact with them, again, with the TTPs of the commonly used port and the standard application layer protocols. Afterwards, the attackers use these engineering protocols to modify the control logic and the parameters on the PLCs, likely using the vendor engineering software. Now, this implies that for the PLCs which do have key switches which regulate this, they were either left in programmable mode or this mode could be overridden in software. It shows the attackers had at least some basic OT knowledge and probably some understanding of the process as well, which is something that we would emulate by using the program downloads, the modify control logic, and the modify parameter TTPs. And finally, the attackers attempted to increase the chlorine levels, and depending on how complex this attack was, this could have led to either chlorine poisoning, or if excess chlorine was detected at a later process stage, it could have led to pumps shutting off during a heat wave. Now, luckily the attack was detected in real time and the actual impact was prevented, but it might have been the case that any other target, this would have not been so lucky. So manipulation of control and the last stage of the attack cycle would be simulated with this particular TTP. Now, MITRE ATT&CK has the benefit of also coming with mitigation recommendations for each TTP, which gives the red team scoring card automatically some directions for improvement as part of the results. As far as mitigation in this case go, properly segmenting and restricting access to the sites in question would have been the top priority. There's no reason for these systems to be exposed to the internet at all, let alone without any form of access control. A red teaming engagement would also have uncovered these highly exposed systems much earlier. From the process protection point of view, secure OT programming and monitoring practices could have aided in reducing the potential impact. So even if attackers manage to get within your OT systems, being able to have some visibility deep within these systems will allow you to detect certain attacks before the impact can actually be delivered. One measure that was reportedly taken in the aftermath of this was installing out-of-band monitoring systems by using live fish, which were put in a sampling tank and monitored for suspicious activity, with the little fish reacting faster to changes in the water, while the bigger fish reacting to build-up effects in the water quality over time. And obviously, because this is out of band from the rest of the process system, that means it's, well, essentially unhackable. And having these various mitigations as a result of the findings of an engagement would allow you to put them in place before any actual incident occurs. So if you're interested in more ICS-oriented webinars, we have several excellent ones available for you. one on performing OT risk assessments, and one on securing remote access and maintenance, which you can check out for free. I'd also like to remind you again about the upcoming webinar on the OT cyber attack database on December the 7th. So if you haven't registered already, please do. And with that, I'd like to schedule some time for questions and answers.
Thank you very much, Jos, for presenting this this interesting webinar. We have quite some questions that came in. One of the questions is what kind of tools you use in ICS OT pen testing?
That's a good question. There's a variety of tools for various purposes. If once you are in the OT environment, one of the first things that you want to do is get as good a situational awareness as possible. You need to know what kind of systems live there, what protocols are being spoken. Because in a red teaming scenario, you go in quite blind. All the information you have is, well, only the information you can hack from the target. So maybe we have some information from IT systems, but typically we are fairly blind as to the OT protocols and systems being used there. So one of the things that we use is, for example, Marlin, which is a free and open source mapping tool from the NSA that has some OT protocol knowledge, and you can take a PCAP that you've recorded from the environment, then load it into Marlin, and once you load it in there, you get an overview of some of the protocols and systems. Of course, we also have some more proprietary network scanning tools that are being used to develop some situational awareness, but you can get quite far with the available open source tools. Then the step after that is, once you have an idea of the systems that live there, you will need to be able to speak some of these proprietary protocols. And for that, we often develop custom capabilities. So we will reverse engineer a particular protocol, maybe not fully, but we'll reverse engineer it to the degree that is required to talk to these devices in order to get some information out, like at least the firmware version, or be able to maybe even do a firmware upload or get some sensitive information from the device. So the deeper you get into the OT environment, the more custom capabilities you will need to develop, because there's, well, basically said, there's not a lot of tooling out there for ICS systems. Metasploit has some modules, for example, but they're tailored only to the most popular protocols like Modbus or maybe Siemens S7. But there's a wealth of proprietary stuff out there that you will have to start digging into yourself if you want to attack these systems.
Okay, thanks. Another question is, how is threat intelligence integrated in the development of attack scenarios? Yeah,
that's a very good question. So during the first phases, when we're looking at the threat landscape, we try to look for relevance essentially in two ways. One of the ways is by just looking at the organization's own high consequence events. So what are the scenarios you're trying to prevent? What exactly would be the worst case scenario? And the other one is, what are people out there doing? Like, have similar organizations or have other organizations within the sector been targeted by certain threat actors? If that happens to be the case, we take threat intelligence from these incidents and we try to incorporate that in the development of our scenario. So take TTPs from these particular incidents and distill them and integrate them into our adversary emulation plans. I do have to say that I'm not a big fan of just taking ready-made adversary emulation plans from existing incidents and just emulating that, for the reason that if you only do that, you're just chasing yesterday's threats. You will always need to take what is out there and what has happened in the past and then contextualize it within the particular scenario you're trying to emulate. So this is really a balancing act between your own insights and the actual stuff that's happening out there that you're getting from threat intel.
Okay, agreed. Are there any specific scenarios where you attempt to modify the logic? I think the logic of PLCs, for example, I think that's meant.
Yeah. So you might, like, it depends on the kind of attack scenario you're trying to craft. In some cases, it might be enough, for example, to just write a certain value to a Modbus register or to write a value to an OPC tag that essentially changes a particular value, like a valve going open or closed, or a temperature set point being changed. In some other cases, the logic itself will have built-in safeguards. So it'll say have a sanity range, for example, on a temperature value. It'll say I will never go higher than this or lower than that. In those particular cases, or in cases where you want to achieve something that the process was never designed to do, you'll have to modify the logic. And essentially that you might have to modify the logic at multiple places because, for example, at a later process stage, certain actions are taken that would nullify your attack that is upstream from that. So yeah, it depends on the attack stage, but in many cases you can escape the need to be able to modify control logic. Yeah.
Okay, this is also a very interesting question because I think a lot of companies think if we have air-gapped it, then we're safe. And this question is about if you have an air-gapped environment, what kind of scenarios can you execute?
Well, it depends on the definition of air gap. I mean, this is a long-standing discussion in the OT world because historically, a lot of these environments used to be actually air gapped. I think a lot of people use the word air gap, but they don't have an actual air gap. So they'll have, for example, an environment that has a limited amount of connectivity enforced by a firewall, or they'll have a air gap from the point of view of network cabling, but they'll still have like wireless connectivity, maybe regular wireless, maybe industrial wireless, or they'll have radio networks. So I think the first question you have to ask, are we actually air gapped? If the answer is no, then I mean you're dealing with a regular red teaming scenario. If you're actually air gapped, then you're delving into a little bit more nuanced scenarios. I mean, reportedly, the Naftans facilities in Iran were actually air gapped, and they managed to get reportedly a USB stick in there by means of a mole. So you could simulate something like that, essentially the malicious insider, by gaining physical access to some of these locations and implanting a rogue device. Or you could, for example, simulate a supply chain attack. Let's say you have an air-gapped environment. Once in a while, you have to renew network equipment. You have to get new keyboards, mouses, all that sort of stuff. So what if someone, compromises a supply chain player? Now you can simulate that and be able to get your initial access there. And once you have your initial access through a software or hardware implant, you can do regular red teaming from there. So that would be the way you would emulate an attack on air-gapped environments.
Yeah, your answer is a nice bridge to the next question, which is about supply chain attacks. How do you approach a supply chain attack? Do you work with a real business and add them to the white team?
So this is always a difficult thing for many reasons. Obviously, vendors, third-party vendors, they're not really jumping for the opportunity to be cast as a potentially exploited party. So one of the ways you can emulate supply chain attacks is by essentially looking at your core supply chain dependencies. So let's say we have a SCADA server. We're looking at the people who built the SCADA software. We're looking at people who build third-party plugins, and maybe we're looking at the people who do remote maintenance. And these three parties, we look at how they're plugged into the system. So one party runs, the software. One party has a few DLLs that are plugged into the software, and another party has RDP access. And you can simulate essentially a breach of all of these. So we can say, okay, let's assume the party who developed the plugins, they get compromised. What would that look like? Well, that would look like their software being manipulated with a backdoor. And that would look like a malicious DLL being loaded by the SCADA server. So we can simulate that without going through all the hoops and nuances of vendor relations, essentially saying, okay, so we start from the assumed breach point of view of having a malicious DLL, which will place on this SCADA server, and then we'll have to do everything from there. So essentially take that complexity out of the nuance by starting your assumed breach somewhere in the attack tree. but starting with the constraints of what it would realistically look like from the point of view of a compromised supply chain partner.
Okay. A question about the attack in Israel. Do you know how it was detected? How did they find out?
I haven't read anything about it. I mean, there's obviously various reports around this, and I'm not sure if you can, if all of them are realistic. Some people say it was the result of like something equivalent to a national detection network. Other people say it was just the result of process operators at the water utilities themselves noticing something was wrong. There's no really conclusive evidence either way. I think both would be plausible, but what you often see is that these attacks were relatively low-hanging fruit, so to see. The operators had some OT knowledge, the attackers, but they weren't very professional, very stealthy. So it's very likely that actually the people, the process operators at the water utility detected things going on. Maybe alarms were being raised. And this is one of the things you have to take into account when you want to do realistic red teaming, is that you're not only evading security measures, but you're also evading the attention of process operators who, well, are 24/7 watching these processes like a hawk. So you have to take that into account as well when you're designing your attack scenarios.
Okay, another question. How long is a typical red teaming engagement from preparation phase to wrap up and presentation of the outcomes?
Yeah, it's a good question. I mean, obviously this really depends on various factors. It depends on the size of the environment that you're targeting. It depends on what pieces of it you want to red team. Do you want to red team the entire environment, or are you only interested in a particular sub-process? So scope is very important. Another important aspect, obviously, is the actual execution time versus a running time, because there's a certain amount of time you spend on the attack, but you don't spend necessarily all of it consecutively. You might stretch it out over a longer period, because some of it requires longer intel gathering. It requires being stealthy, so you move a little slower. And realistic attacks, I mean, they're spread out over a longer period of time as well. But in any case, it's always within a certain order of magnitude that's months. So it's definitely a much longer trajectory than a regular pen test, because it's much wider in scope. It's much it's much more realistic. So you're always dealing with a much bigger investment than a regular pen testing engagement, because it's a much bigger type of engagement.
Yeah, and it also depends. That we know from experience that it's also dependent on if you have a single red teaming or you do a multi-year program. If you have a multi-year program, you can divide your attention to several years and several attacks and several TTPs. So that could also be quite different. But it's usually like the running time is in months mostly. Another question. I think we are almost getting to the end of time, and we have more questions than time allows us. So we will get back to you with a question. And also, please feel free to contact us. In the next slide, we'll show, I think my email address is there, and you will find it on the website. You can always contact us with additional questions. Last questions. What tools are used to monitor OT attacks? Are they the same IT tools like SIEM, or are they different?
So within the OT space, there are dedicated OT intrusion detection systems, and these are different from the regular IT intrusion detection systems, mainly because they have in-depth protocol knowledge about all these proprietary protocols, about these systems. They can contextualize them differently, because obviously you need to contextualize where a certain attack is taking place, what this particular system is doing. But these can often be integrated within a central SIEM solution. So depending on the setup of your SOC, you might have a SIEM that gets fed information from the regular IT intrusion detection systems and the OT intrusion detection systems in a single SIEM. And they have typically integration capabilities for that. But yeah, it's a different set of tools and solutions because it's a different technological environment.
Okay, one very last question that just came in, and I think it's interesting. A lot of companies might ask themselves this question: how can we determine if we are ready for a full red teaming engagement, or do we have to work? Have we work to do before we can launch something so comprehensive?
Yeah, that's a very good question. I mean, red teaming is, of course, something that is fairly high up the maturity scale. So if you've never done any sort of even like, let's say, compliance or awareness, you're not going to get a lot out of red teaming. But once you move a little up that maturity scale, red teaming usually starts to pay off when you want to look at your organization holistically. So even if necessarily, like there's not a benchmark, a quantitative benchmark where you can say, oh, we do this many pen tests per year, now we're ready for red teaming. You're usually ready for red teaming when ironically, when you think you're ready for red teaming. So if you think, well, we should be relatively good in a lot of areas, but we're not quite sure, or we're good and we're convinced of it, but we want either proof to the contrary or maybe proof not to the contrary, then red teaming is exactly what you're looking for. So it's usually something you do once you feel like you've achieved a certain level of confidence in your security posture. Like if you're very aware that you're extremely vulnerable, there's other things I would prioritize. But once you've reached the level where you say, well, show us our blind spots, then exactly that is where red teaming should come in.
Yeah, and I also have the experience that companies can start. You can do a very complex and large red teaming assignment, and you can also start with what we call red cell assignments, which are then you pick out some elements of a full red teaming, and then you use that to start up testing your cyber resilience in a more holistic way. So you can always start a little bit smaller and then build it up over a program. Okay, thank you very much, Jos, for taking us out in this very interesting topic. Again, I would like to point out that please fill in the evaluation form. We will get back to other questions to you later on in another way. So we will email you. You can always email me. You see my email address is over there. So please let me know if you've any additional questions. We couldn't answer all the questions in this webinar, but we will get back to you. Thank you very much for your time, and I hope to see you again on December 7, at least for the ODCAT webinar, which is very much in line what we discussed here. Thank you very much. Goodbye. Have a nice day.
Thank you.